In this video I'm going to have a look at the 1994 question 1a. So in the question we have a lift which is in continuous descent and it has a uniform acceleration of 0.6 meters per second squared for the first part of its descent and a retardation or deceleration of 0.8 meters per second squared for the remainder. The complete time from rest to rest was 14 seconds. Draw a velocity time graph and hence or otherwise find the distance descended. So I've drawn the velocity time graph because I think you should be okay with that now, just to fill in one or two details. So initially the lift is accelerating, so its speed is increasing at a rate of 0.6 meters per second squared. So we know that that's equal to the slope of this line. And then it's decelerating at a rate of 0.8 meters per second squared. So that would be the slope of this line. We don't know the maximum velocity, so we'll just call the maximum velocity v. We know the total time was 14 seconds, but what I usually do and what you should do is you should split this into two kind of sections, section 1 where it's accelerating and section 2 where it's decelerating. And let's call the time for it spends accelerating t1 and the time it spends decelerating t2. So that's part 1 done. Just fill in as much detail as you possibly can. Now what I'm going to do first is I'm just going to show you the theory behind what you need to solve this question, but you don't actually have to include this bit in your answer. It's just something that you might want to know where it comes from. So let's say I look at section 1 and I want to get an expression for the final velocity v. v equals u plus at. Well, for section 1 v is equal to, or u is equal to 0, its initial velocity is equal to 0. Let's call this acceleration a. So we've a times t1, so v is equal to acceleration a times t1. Rearrange that, we could say acceleration a equals v divided by t1, which is just an expression for the first acceleration. I'm going to do the same now for section 2. For section 2, v equals u plus at. Now for stage 2, the final velocity is 0. The initial velocity is actually v because we're starting here where the velocity is v and the final velocity is 0, and let's just call this rate of acceleration b for the purpose of this question. So it's a deceleration, so it'll be minus b times t2. That gives us v equals b times t2, or b equals v over t1, t2. Now I'm just doing this to kind of get a ratio or a ratio of the difference in accelerations to the difference in times. So you don't need to do this for your answer, as I said, it's just kind of to show you where it comes from. So let's say I get acceleration a and I divide it by acceleration b. That's the same as v over t1 divided by v over t2. V's will cancel, which gives us 1 over t1 divided by 1 over t2. Which is the same as t2 over t1. So therefore a divided by b is the same as t2 divided by t1. And that's the important bit that you need to remember for this type of question. You can use this without having to do all of what I've just done there. That a divided by b is equal to t2 divided by t1. Or another way you'll often see it written as the ratio of a to b is the same as the ratio of t2 to t1. So that's an important fact that you want to remember, and you use it in this question and you also use it in the questions where you have no speed limit. And I'll go through a few more of those with you as well. So let's apply it to our question now. Acceleration A is 0.6, acceleration B is 0.8, and we're saying that's the same as the ratio of T2 to T1. Just going to simplify this ratio a bit, so that's the same as the ratio of 6 to 8, which is the same as the ratio of 3 to 4. So how many parts have we? We have 7 parts in total. T2 is 3 of those parts, and T1 is equal to 4 of those parts. Now we can use our total time to solve for T1 and T2. So the total time is 14 seconds. So we want to split that 14 seconds into a ratio of 3 to 4. So one part will be 14 divided by 2, which is, divided by 7, which is 2 seconds. So then that means T2, which has 3 parts, will be 6 seconds, and T1, which has 4 parts, will be 8 seconds. So now we figured out what T1 and T2 is. We can put that on our graph. So going back over here, T1 we figured out was 8 seconds, and T2 was 6 seconds. And when you look at your graph, it makes sense that T1 is bigger than T2, because here we have a lower acceleration, which means we have a lower slope. Here we have a higher rate of deceleration, which means we have a higher slope. So obviously, the areas under these graphs are going to be kind of the opposite of the rates of slopes. In other words, smaller slope here, but bigger time. Bigger slope here, smaller time. So that's part 1 done, and a bit of theory on the graph. Now find the distance descended. So you should know at this stage that distance travelled is equal to area under the graph. We have a triangle shaped graph here, so that's going to be half the base times the height. Now the base we know is 14 seconds, the height is v, so we need to figure out what v is, and that's why we need to figure out those times first. So v equals u plus at, so I'm going to just use stage 1. The final velocity is the initial velocity, which is 0, plus acceleration a was 0.6 times t1, which is 8, so the final velocity is 4.8 seconds. And now we can use that to find the area under the graph. Oh, sorry, I don't know what happened there. So distance is going to be half base times height, which is 1/2 the base, which is 14, and the height we just figured out is 4.8. And type that into your calculator and you should get an answer of 33.6 meters. And that's the question done.